طب, as usual, please register your attendance by typing in the chat panel your ID. Of course, you should type your own ID. Don't type anyone's ID, just your own ID. And do it once, please. Don't repeat yourself. Just do it once at the beginning. Okay. We'll give another 30 seconds. Let's give 1 minute. 1 minute. We'll give another 1 minute for you to type in your ID in the chat panel. Everyone should type your ID in the chat panel. Only do it once and only type your own ID. Don't type someone else's ID. Okay, 30 seconds left. 30 seconds left. Everyone should type his ID in the chat panel. Just do it once and type your own ID only. Don't type anyone else's ID. I can see. Okay, 15 seconds. We need to start, ya shabab. 15 seconds. 10 seconds. Last opportunity to register your attendance. 5. Okay, thank you very much. طيب. Now, we would like to, before I give you this important example, we like to give you some introduction about it. So here we discuss objects that they are in contact. Contact means they are in contact, they're touching each other, and we apply a force on one of these objects. What is the effect on either on that object or his neighbor? So let's see. So here I have this object and I will call it A. Okay. And I have it in contact with another object. I will call it B. So I have two objects, A and B. Now, if I apply a force here on this side on A, of course, the force is applicable. So this will call it F applied. If we apply this force on A, and if the objects, they will move together, right? If they will move, assuming they will move, say there is no friction, for example, assume they will move, they will have to move together. If they move together like the objects connected by a cord, so they move with the same acceleration, okay? They move with the same acceleration. So what is the best way to calculate this common acceleration, the same acceleration? If the best way to calculate this acceleration is by taking them as a unity because they move together. So I will say the following. F applied, this is the only horizontal force. Here we say no friction. If there was a friction, I have to add a friction force here, but here we don't have friction. F applied is the mass of A, because they are unity now, plus the mass of B, okay, multiplied by the common acceleration. So this is a Newton's second law, F equal ma, okay? Now, bear in mind that inside you have hidden forces, forces of contact. There is a force on A due to B. So here, there is a force on A due to or from B. And there is an equal force on B. Notice the direction of the arrow. due to A. Once I do this step, I basically say these two forces are equal and opposite, so they cancel out. So they cancel out. Okay? So because of this, by doing this step, and if I know the applied force and I know the masses A and B, I can get the acceleration. But once I get the acceleration, what I can find, can I find those internal forces, the contact forces, FAB? Yes. Now, what are the forces on A? So forces only on A. Forces only on A. Could تساعدوني? Yes. I have on A is affected by the applied, and there is this force, F on A due to B. So F applied, which is positive, in the positive direction, minus, because this is in the negative direction, talk about this one, minus the force on A due to B. Of course, if there is a friction, I need to add it. Should equal what here on this side? F equal MA. Only the mass of A, because I'm saying the mass of A. So mass of A multiplied by the common acceleration. Multiplied by the common acceleration. Now, how about forces on B? Forces on B. What is the force that you see on B? On B, only I see, oops, I made a mistake. So here I have A, and here I have B. What is the only force on B? The only force on B is this one. It is force on B due to A. Now, if I want to write Newton's second law for this, applied is not applicable here on B, right? So it will be what? Force, the only force affecting B, force on B due to A should equal mass of B multiplied by the common acceleration. And I can find this force because I know the mass, and from the first step, I know the acceleration. Now, something to know is that if AB magnitude should be what? FBA. Yeah, because these are contact forces, equal and opposite, like Newton's third law. Right. Let's advance this, and let's say now I have three objects. I have A, and I have B, and I have C. Now, if I apply a force here on this end, F applied, what is the common acceleration? So how to find first the acceleration? Then أول step, find the acceleration of the whole system. Those three masses are in contact. So it will be F applied, يعني external force, will equal MA plus MB plus MC. All of them is one unity by acceleration. If I know the masses and I know the applied force to the left, I can find the acceleration. Once I know the acceleration, now we need to add something. What are the forces on A? A is affecting by this force, but A is also affecting B on this side. Now, how about this contact here? There is a force from C on B, and there is a force from B on C. Those two are equal, and those two are equal. Now, you see the difficulty. If I ask you to find the forces on B, you need to have knowledge about this force and this force, which is difficult. What is the easiest particle to ask the force on? On the chat panel, what is the easiest particle, A or B or C? No, it is C. Why? Because if I ask you about A, you need to know this force, which is B on A. But C only has one force affecting it. So on C, what are the forces on C? It is F on C from B, which is which force? This one. Should equal what? Mass of C multiplied by acceleration. I know the acceleration from the first step, and I know the mass of C in the question, so I can find the forces on C. And by the way, this is the mass always they ask you about, which is the third one to the right. Yani last one is the one usually they ask you about. Here, the last one in the first example is B, and only one force affecting B, which is this one, F on B due to A. So we have the same manner. We have the same manner. And now let me show you an example we have. The example we have is basically two objects. I have A and B, and the mass of A is 4 kilograms, and the mass of B is 6 kilograms. Okay, here. The applied force is 20 Newton. إذن هذه applied force is 20, okay, to the side. This one, mass A is 4, mass B is 6. And he said, what is the acceleration of the blocks? We said the first step, so this step is wrong. We cannot say the acceleration only the mass of A. No, both of them in contact. Both of them move together. So this is a wrong step here. I put it a cross on it because it's wrong step. The correct step is to say the following. F applied equals the mass of A plus mass of B multiplied by the common acceleration. From this step, when we solve, we know the mass of A, we know the mass of B, and we know the applied, we get the acceleration too. Means the whole system is moving to the right with 2 meters per second square acceleration. They are connected together. They are in contact. Now, question B, what is the horizontal force on a block B from block A? Where is on a block B from A? Where is it? This one. هذا اللي he's asking about. B only suffers from this force only when he wants it. So what I need to do? The only force on B is from A, which is equal to mass of B only multiplied by A. I know the mass of B and I know the acceleration. So the answer is 12. 6 multiplied by 2, mass of B, by the acceleration I found from the first step is 12. Now, in order to check, we know that the FAB should equal the FBA, the force of contact, equal and opposite. Can you check for me that the force on A due to B, اللي هي هذه الفورس, is the same as force on B due to A? Yeah, let's ask the question. What are the forces on A? The forces on A are the applied to the right, هذه, well, F from B on A to the left. So this is with a statement. Now, what is the applied? Is it 20? 20 Newton in the question. And what is the mass of A? Mass of A is 4. And what is the acceleration? Is 2. So can we know now, take this to the other side, FAB will equal to what? 12 Newton. 12 Newton, which is equal to this force. So here we proved from this example that the force on A due to B is equal to the force on B due to A. Remember the arrangement of the steps. First, we have to find the common acceleration. In the common acceleration, we delete any contact forces. The forces in between, we're not interested in because they're equal and opposite. So they will cancel out. So I'll take an applied, and then I add all the masses multiplied by the acceleration. Knowing that, I know acceleration. Once I know acceleration, I started to say each particle, what are the forces affecting each particle, including the contact forces, and I can solve. In case I have a friction, I have to add the friction force, as we will see in the examples. This is a common example, and usually they give you questions about similar to the elevator idea. طبعا, if you attempted to solve the questions that I gave you, that we will review, inshallah, in the coming, at the end of this week, if you notice, we have a few examples on 3 particles and 2 particles, and I want you to attempt solving them. We'll come back, inshallah, to these when we do the review session. Right, good. Now, here we start chapter 6. So chapter 6 is mainly dedicated to force and motion, but now we have an emphasis on 2 things, the friction forces and forces related to uniform circular motion. Okay, so what is the friction force? Remember or recall that when we talked about the friction forces, we said the force of a friction is usually given by a curved F like this. And it's a vector quantity, by the way. Yeah, it is a vector quantity. And we said the force of a friction direction is opposite always to the direction of motion, and it's between 2 objects. يعني, I have an object here sliding on the floor here. Here is a floor. There is friction. If you apply a force here, big F, you try to pull it to the right, and there is a friction, there is a force here that is here, and it's opposite, and it's along a surface. This is called force of friction, and it's called F. مايلة كده ال F. Okay? So how can we judge when I have friction and when I don't have friction? Imagine you have a particle that is stationary on a surface, like this particle here, A. This particle, a box, this orange box, is on a surface that this surface is rough, is not smooth, so there is friction. But if I ask you now at this stage, what are the forces affecting this particle in A? You will say, oh, there is a force I learned, I cannot ignore, which is force of gravity, correct? And because I have surface, I have a force, a normal force up. Do you have any other force? Someone will say, but you told us there is friction. Yes, but the force of friction will not act unless there is attempt of movement. يعني the force of friction will not act as long as, يعني here in this situation, because no attempt to move the object either to the left or to the right, then force of friction is zero. So frictional forces here are zero because there is no attempt, there is no resistance. The force of friction, remember, it is a resistance. Air friction maybe? No, we're not talking about air friction. I'm talking about friction. I'm talking about friction with the surface. I'm not talking about air friction. Air friction in this course is totally omitted, is ignored. I'm talking just about two surfaces. You drive on an asphalt road, okay, on the highway. There is a friction between the wheels, the tires, and the asphalt due to the roughness of the wheel and roughness of the street. Okay, so you have a friction. I'm talking about specific friction between surfaces. I'm not talking about air friction here. Okay, so question here: when you have a smooth type of surface, if oil was it's okay. If there is an oil, he will tell me in the question that frictional forces are ignored. There is no friction. It's a frictionless surface. It's a very smooth surface. He will tell me in the question. He will not leave me in the dark. Okay, but for now, I'm saying if there is a friction, it's here is zero because there is no attempt to move the particle either to the right or to the left. Now let's take situation B. In situation B, there is an attempt. You see this force I put a circle on? It's trying to pull the object to the left. So what happens? If the surface is rough between the box, the orange box, and the surface, there will be a force of friction. Notice that we give it here subscript S. Subscript S is to indicate static. Static means the object is still stationary, but there is friction. كيف يعني؟ Yeah. You try to pull it to the left. If there is no friction, you should be able to move it. But if it didn't move, what does it mean? It means there is a friction here that resisted this big F. So this resistance or this friction, we call it F sub S, which means static frictional force. By the way, the question is, how much is this static frictional force? It depends on the force you're applying. If you apply 1 Newton, the friction will apply exactly 1 Newton, static frictional force. If you apply 5 Newton, the static frictional force will apply 5 Newton, so that to keep the object in a standstill situation, in a stationary situation. But if you apply certain strong force, يعني let me tell you this example. It's difficult with virtual learning to explain this. Imagine you have a baby صغير, طفل صغير. And he's trying to push a desk. الديسك اللي انت جالس عليه في البيت, طاولة, table. There is, of course, a friction between the legs of the desk or the table and the floor, whether it is carpet or just the floor. If the baby is weak, and he tried to apply 1 Newton to push, maybe the table will not move. It means the friction force opposite to the baby pushing force is exactly the same force the baby applied. If another baby helps him and 2 babies applying 2 Newton, now the friction force will try to apply 2 Newton in the opposite direction. So how about if I bring 5 babies and they push the table together? They will be able to move it. Here, I don't have a static. Here, the table will slide. And it's called kinetic frictional force. So frictional force, I have 2 types. I have a static frictional force, and this force is variable. كيف يعني variable؟ تتغير. When you put one baby, it became 1 Newton. When you put two babies, this force became 2 Newton. When you put 4, it became 4 Newton. So static frictional force is variable. Notice here, if we increase the force, زي example 2, 3 babies, for example, static will oppose it, and still they are equal and opposite. So the object in this case did not move. If you put 4 babies, the static frictional force will be 4 Newton. So still did not move, okay? Bear with me. Bear with me, okay. Still did not move. لغاية الآن we call it static. Now what happens when I added 5 babies? When I had 5 babies, I managed to overcome the friction force. And now notice this subscription, because now the object is sliding to the left with acceleration. So this force now is called kinetic frictional force, because it's now moving. It's okay. You can be sliding and having friction, which is the same application. When you slide an object, you push a box on the floor, it's sliding, but there is a friction while it's sliding. So this type of friction is called kinetic frictional force. Kinetic frictional force. طيب. Now, this weak frictional force, okay, this kinetic frictional force, and we have a static frictional force, we need to be specific about them. A static frictional force is a variable force. It keeps changing, but it has a maximum. هو متى حصل الماكسيمم؟ The maximum of a static frictional force when I had 4 babies and between 5 babies, they managed to move it. So up to 4 babies, this is called Fs maximum, which means the maximum static frictional force. Beyond this, if you apply a force greater than the Fs maximum, you will manage to slide the object, and Fs will die out, becomes Fk. Okay? So Fs is variable. That's why we cannot calculate it. By the way, يعني ركز معايا. Fs ما عندنا equation. We don't have equation to calculate the static frictional force. Why? Because it's variable. I don't have equation for it. But the Fs maximum, I have equation for it. So here, if you apply 1 Newton, it will apply the friction 1 Newton. 2, 2, 3, 3, 4, 4. هذا ال 4 is the maximum frictional force up to here. Beyond that, what will happen? The static will die out and it will become kinetic. And here it is constant, it's not variable. The kinetic frictional force, notice the curve, this one I'm trying to, horizontal one, is constant, is not variable. I have a law for it. I will show you the laws. So I don't have a law for Fs, static frictional force, but I have a law for Fs maximum. The reason Fs is a variable force. I have a law for Fk, which is mean kinetic frictional force. The reason it's a static force. When Fs will be in action, when the object doesn't slide. When Fk will be in action, when the object is already sliding. طيب, good. Good. Let me show you the laws I'm talking about. So here we give you a summary. We go back to the summary. We said we have 2 types of friction. We have static frictional force given as Fs, and the direction we know it. No need to talk about direction. It's opposite to the movement. But in terms of magnitude, it is, I will tell you the law. Now, I did not give you for Fs. What did I give you? I give you a law for Fs maximum. Why? Because we said Fs maximum, we can calculate it, but we cannot calculate Fs. We cannot calculate Fs because it's variable. We can calculate Fs maximum. What's the law of Fs maximum? It said µs al-Fn. Wait, what's this? µs is a coefficient. It's called coefficient of static friction. وهذا الcoefficient intrinsic property. It depends on the roughness of the 2 surfaces, the street and the box, the floor and the box. So µs is a constant. Usually it's less than 1. And what about Fn? هذه ال Fn النورمال force اللي تعرفها قبل. Oh, is it? Yes. يعني here, when I have the box, I have Fg and I have Fn. I need the Fn. The Fn is important. The Fn is important to calculate the friction force magnitude. Because here it tells me the Fs maximum is a coefficient called coefficient of static friction, µs. less than 1 and it depends on the roughness of the two surfaces. إذا هذه ما لها علاقة بالسؤال، لها علاقة بالnature of the floor and the box. والFN is the normal force. By the way احنا الFN ثابتة ولا نقدر نغيرها؟ الFN تتغير. كيف تتغير؟ حسب السؤال. كيف؟ and I'll show you. What if you applied a force with an angle here and I ask you to calculate the Fn? Is the Fn still mg? No, the Fn is not equal to mg in this situation. This force will be analyzed into this force and this component. Now the Fn equals those two forces together. إذا ال Fn can change, depends on the question. Not always. يعني ما بقاك تحفظها تفكر إنك يعني you're doing yourself a favor by saying Fn equals mg على ال horizontal surface. No, that's not the situation. Or على ال incline. تتذكر ال incline؟ قلنا ال Fn equal mg cosine. Yeah, if there is only those two forces only. Fn equal mg cosine theta. But if I add a force here, things will change. The Fn can modify. So calculating the Fn is the first step to calculate the magnitude of the frictional force. إذا ال Fs maximum is made of mu s Fn. Oh, by the way, similarly, the Fk اللي هي kinetic frictional force is made of another coefficient. It's called coefficient of kinetic friction, mu k, multiplied by also Fn. And notice here how the Fn is important. The Fn is extremely important. Without knowing the normal force, I cannot calculate the friction forces. I cannot. Let me see. Anybody has a question? Let me see. Can you repeat how Fn is changing? Yes, Fn is changing depends on the questions. If I only have, I'll repeat it. I'll repeat it. If I only have this box, and what are the forces on it? Fg, Fn. Yeah, صحيحة. هنا ال Fn equals mg. Now you have the same box, but you apply this force here. So what you have? You have Fg, وhere you have Fn. ال Fn الآن doesn't equal Fg. هنا ال Fn equals Fg. Fn equals Fg. صح. But here no. Why? Because I need to analyze this force. Two components. الآن وش تصير الإكويجن؟ Fn plus هذه الإف في الأنجل كوساين. F كوساين equals Fg. هذا الترم زاد على Fn. Now Fn is different. So Fn can change. If I add a force with an angle, Fn can change. You agree with me? So Fn is not always I memorize it Fn equal mg. هذه one of the most common mistakes that the students make. They assume إنه Fn equal mg أو إذا كانت incline Fmg cosine theta. Is not correct. If you add a force to the question with an angle, Fn will become different. You need to analyze into components and see. Equate them. Say the force is up because it's on the surface. The force is up should equal forces down, and you can solve. And you can solve. So here we go back. The Fs maximum has a law mu s Fn والFk الكاينتيك هذه ما لها maximum هذه constant already mu k Fn. طيب good. Those two laws, by the way, those are magnitudes. How about the direction? A direction is always opposite to the direction of motion. مش مهم عندي الآن. Always opposite to the direction of motion. Just bear with me here 1 second. Let me see. Okay. طيب. So if the body does not move, then the applied force and the frictional balance along the direction parallel equal in magnitude opposite. We said the static frictional force. One baby does not move means the force by the baby 1 Newton is equal to the static force, not maximum, static 1 Newton. I don't have a law for Fs. I have a law for Fs maximum. So we said the magnitude of Fs maximum is another way to repeat it. Fs mu s Fn. This mu s is called coefficient of static friction. By the way, what should be the unit of mu s? يلا ساعدوني. على الchat panel, what should be the unit of mu s, the coefficient of static friction? On the chat panel, everybody should know. أنا أتوقع the 100 students should answer. Yes, no unit. لا مش نيوتن. No unit. Why? Why no unit? هذه force نيوتن وهذه force in نيوتن. So what should be the unit of mu_s or mu_k? It's just a coefficient. It's a number. It's a parameter. It doesn't have unit. It's unitless, dimensionless. Because the left side, Fs maximum or Fk, is in newtons, while normal force is in newtons. So it should be what? It should be what? It should be unitless. It should be unitless. طيب. So here. طيب. So الFK mu K Fn, well mu K is called coefficient of kinetic friction. What should be the unit of mu K? It's unitless. Why unitless? Because the FK is in newtons, well normal force is in newtons, so both of them. So here, magnitudes of normal force measure how strongly the forces are pushed together. هنا ممكن واحد يفكر يقول what is the relation between a normal force والfriction? إذا كان الsurface is pushing with different normal force, هي أنت when you push something to the floor down, you're affecting the friction. يعني imagine أنك أنت تضغط بيدك على قطعة like this down, somebody is trying to push in this direction, you're affecting the friction. Why? Because you change the normal force. إذا the normal force has direct impact on the kinetic or static frictional forces. طيب. Here we said the values of the frictional coefficients mu_s and mu_k. mu_s is static, mu_k is kinetic frictional force, are unitless. By the way, usually mu_s is greater than mu_k. Usually in most surfaces mu_s is greater. دائما بالأسئلة حتشوف حيعطوك mu_s مثلا 0.4, mu_k will be 0.3. So usually mu_s coefficient of static friction is greater than coefficient of kinetic friction. Let me see. Somebody raised his hand. Abdul Aziz Adwayan. Go ahead, Abdul Aziz.
Yes, doctor. I have a question about the friction. Does all bodies have friction even when they're not moving, or as soon as we start applying force, the friction rises?
Yes.
Which one?
The second part is correct. The particle does not have a friction if there is no attempt, horizontal attempt to move it.
So as much as I add force, as much the friction rises?
Yes, as long as he is stationary.
Okay.
That's why Fs is changing, because you apply 1 نيوتن. يعني انت تدفع دفعه بسيطه على طاوله 1 نيوتن، المعاكسه 1 نيوتن، 2 نيوتن 2 still it did not move. 9 نيوتن 9 نيوتن. But once
it does have a cap.
It has a cap. This is Fs maximum.
Okay. Thank you, doctor.
Cap. احنا our mission in solving these questions is to know the cap, because once we know the cap, we know if the particle is still stationary or the particle is now sliding. We need to know a threshold اللي هي Fs maximum. Okay? طيب, anybody has a question other than Abdulaziz? What is the between Fn and friction? We talked about it. Fn, if you push on a particle like this example here, you push down and somebody is attempting a motion pushing horizontally, you affect the friction, of course. The more you push, the more you increase a normal force and you increase the friction force. طيب, good. حيدر, okay, good. حيدر عنده سؤال. حيدر المرزوق. Go ahead, حيدر.
Yes, again, why UK is less than US?
In UK, and I'll show you why. Go back to this slide. سؤال جيد. Go back to this slide. Here. Notice that Fs maximum is what? Fs maximum has a max. Let me bring a pen here. Yeah. Where is the maximum? Here. إذن ال Fs maximum, in normal force is the same. Why this became higher than Fk? هذه ال Fk, right? Why? Because mu_s here is make it much more than mu_k. Or not much more, but it's more than mu_k. The mu_s is static. It means it will keep the object stationary. معناه roughness is important here. The mu_k is a friction while the object is sliding, so roughness is not that important here. Okay, طيب, good question. طيب. So now we show you why friction happens. If somebody has a big magnifier, طبعا هنا هذا surface, let me show you. هذا surface وهذا object. هذا object and below is a surface. If somebody brings a very big magnifier or a microscope, he will see that both surfaces, they have mountains and valleys to at. Those mountains and valleys, they cause friction once an attempt is made to slide this object, for example. So the reason of a friction is occurs between the contact points that slide against each other. Greater force normal to the contact increase the friction because, yeah, a normal force, if somebody is pushing here with a force down, means the Fn is greater, is big, means the friction force will be big. Okay, so this is the reason of a frictional forces is microscopically because I have valleys and mountains between two surfaces, the ground and the object, and once an attempt to move it horizontally, you cause friction between them. You cause friction between them. طيب, let's take this question. فركز معانا. We solve it together, okay? A block lies on the floor. What is the magnitude of the frictional force on it from the floor? ها؟ هذا سؤال زميلكم عبد العزيز قبل شوية. An object is on the floor. What is the magnitude of the frictional force between the object and the floor? 0. Why 0? There is no attempt to move it. Object lying on the floor. There is no horizontal force to attempt to move it. So the friction is 0. Exactly your answer. B, if a horizontal force of 5 Newton is applied to the block, but the block, شوف the information he has to give you, but the block does not move, what is the magnitude of the frictional force? 5. And by the way, if he applied 4 and it doesn't move, what is the magnitude of the frictional force? It's 4. If he applied 3.5 and it didn't move, what is the magnitude of the frictional force? Is it 3.5? That's why we said static frictional force is a variable force. I cannot calculate it. I cannot calculate it. It keeps changing. Part C. If the maximum value اللي هي FS maximum, هذا اللي threshold اللي الكاب اللي تكلم عنها زميلكم, of the static frictional force is 10. Will the block move if the force applied horizontally is 8? طب ما هي الكاب 10. هذا ال FS maximum. يعني even if you apply 9.9, the object will not move. If you apply 10, beyond the 10, ال 10 اللي هي الكاب, beyond the 10, the object will slide. So he tells you here in the question, if the cab اللي هي ال FS maximum is 10, and you applied 8, yeah, it will not move. So no, it will stay stationary. If it is a 12, but if you apply 12, well, cab is 10, what will happen? It will move. Well, and in nature of this part in D becomes kinetic frictional force. Now the object is sliding. What is the magnitude of the frictional force in part C? Where is part C? Part C, if you applied 8 في part C, but the cab is 10, what is the magnitude of the frictional force? Is 8. لأنه ما وصلت لل 10. I'm still, I applied 8, he will oppose me with 8. يعني إذا الكاب, ركز معايا, هرسمها هنا عشان أنا عارف إن هذه من الأشياء اللي تلخبط. الآن عندك هنا هذا الأوبجكت. You applied 8. هذه 8 نيوتن. هذه applied. الفريكشن هذه الاحتكاك, ال FS maximum is 10. Will it move? No, it will not move. هذا الماكسيمم. But in reality, what is the friction that causes it not to move? Is 8. إذا ال FS in this case is 8, is not 10. And I know الكاب. If exactly I apply 10, it will not move. لكن if I apply 10.1, if the cab is 10 and I apply 10.0001, it will move, becomes kinetic. If you apply the same force as the cab, it will still be static frictional force, exactly as the cab, اللي هي ال FS maximum. If you apply anywhere beyond this cab, it will slide and becomes kinetic frictional force. We have more important example now coming, inshallah, on this idea. طيب. Let's take this example. This is very important example, okay? A person pushes horizontally with a force of 220 on a 55 kilogram crate. انا حرسم لك اياها. هذه كريت بوكس وفي واحد هنا اوكي pushing horizontally يعني يدفع كذا بهذه الفورس. كم هذه الفورس اللي يدفع فيها هذه فورس؟ So let me draw it like this. 220 نيوتن. Now what are the forces on this object؟ يقول لك انه الوزن 55 so it is 55 by 9.8 هذه تحت هذه الاف جي right 9.8. Also there is a contact so I have the F normal. Okay, how much is normal in this situation? In this situation a normal exactly mg. I don't have forces with angles so a normal force is equal to mg. The coefficient of kinetic friction is 0.35. Yeah, he said pushes means it's in motion يتحرك. ويقول لك a man is pushing him, that's why he give you only the coefficient of kinetic friction اللي هي mu k. What is the magnitude of the frictional force and the crate's acceleration? Then he wants what? He wants Fk magnitude, which is what? Mu k Fn. طب ال Fn here is mg, so I can find it. Mu k is given 0.35 well Fn. Part B, what is the crate acceleration? What do you think should be the crate acceleration? هذه الفورس minus the friction force opposite should equal ma. So let me show you the solution. Here first Fk is equal to mu k Fn. So mu k 0.35 by mass 55 by 9.8. This is Fk kinetic frictional force. طيب part B he said what is the acceleration? أنا عارف إنه عندي applied force minus ال Fk will equal ma. So ال A كم? Just divide by ال mass. What is ال F اللي هي ال applied force? It's given in the question 220 minus ال Fk you just calculated 188.65. So you find the acceleration. You find the acceleration. Let me see. Anybody has a question in the chat? Yes. The acceleration you need to divide by the mass. It will be, you're correct as long because you did not divide by the mass. Once you divide by the mass, 55, you get it. Excellent. Excellent. Okay, good. لأن هذا السؤال أجى بالإكزام many times always people find it difficult to solve. Let's understand it first. A 3 kilogram block, this is the mass of this orange block. هذا old exam question. Is initially at rest. هنا ال big challenge. He doesn't tell you if it's a sliding or not. He said initially at rest, جالس. On a horizontal rough surface, which means there is a friction, horizontal rough surface, there is friction. A horizontal force 7 نيوتن. هذه 7 نيوتن. إذن هذه كم؟ 7 نيوتن. And a vertical force also this one هذه not normal. هذه additional force. ركز معايا ما يتكلم عن normal. يقول أنا حطيت two forces. واحد pulling this way to the right وواحد pulling up. هذا أوكي حر. واحد يحط force up واحد يحط force. هذه not in normal. Something else in normal. لسه لازم نضيفها. Okay. Determine the magnitude of the frictional force if the coefficient of static and kinetic friction are 0.4 or 0.25. يعني أعطاك here notice mu s is greater than mu k. He said mu s is 0.4 or mu k is 0.25. He said tell me the friction. والله هذه صعبة. First of all, I need to know if the object is stationary so that I can use the static law, or the object is sliding so that I can use the kinetic law. How to know? By calculating a threshold, الكاب. And how? What is the cap? قانون الكاب. قانون الكاب mu s Fn. طب الميو اس أنا أعرفها 0.4 but I need ال Fn. كيف أحسب ال Fn؟ بالسيتويشن هذا I need to add mg and I need to add another force up which is what? Fn. الآن حلل الفورس شو تصير؟ Fn زائدا ال B plus B minus ال mg اللي هي الداون should equal what? زيرو. الاكسلريشن على الواي لانها in contact is زيرو. طيب رتب هذه وش تصير؟ الاف ان والايكوال انقل هذه هنا بتصير بوزيتيف وهذه هنا بتصير نيجاتيف. الاف ان ام جي ماينس البي. طب الام جي يو هاف 3 كيلو جرام 9.8 والفورس البي هذه الاب 7 يطلع كم؟ 22.4. هذه 22.4 هذه الاف نورمال. multiply it here by الميو اس. كم طلعت الفورس؟ هذه الكاب. This is the threshold 8.96. But how much he applied horizontally؟ كم؟ 7. هل هي أقل ولا أعلى من الثريشولد؟ أقل. إذا what is the friction of this object? Is it 8.96 or is it 7? It should be 7. The example of the babies, he applied 7. Still he did not reach the maximum or the cap, means the object, the friction force will be static, changing, and it will apply exactly 7. What if this force was 8? What should be the answer then? 8. The frictional force will be 8. What if this force was 8.7? What should be the answer? 8.7. But what if this force, وهذا سؤال إلك, what if this force was 9? If this force was 9, now which law I should use? FK صح؟ لأن تخطيت الكاب. mu k Fn, and here I calculate it will be different than 9. Okay? صح? You agree with me? Everybody agrees with me? Yes, mu kfn, exactly. ممتاز. Anybody has a question on this idea, on this example? The net vertical is 0? Yes, yes يا عزيزي. The object is not flying. The object is in contact with the surface. يعني الاكسلريشن عشان يكون عندي acceleration up or down, يا الobject flying or drilling into the ground. He doesn't tell you, just tells you it is only sliding. Yes. Can you do it again? I can do it again. We need to invest another 5 minutes, which we don't have. I just want to say that I need first to calculate the cap. الكاب mu SFN اللي هي ال FS maximum. I calculated the cap, but I calculated the cap. I need a normal force. A normal force to calculate it, I know I have the FG and I have a normal and I have this force. So once you do the balance of forces, ال FN plus ال B minus ال MG equal ال ML equal 0 اللي هي ال MLY. Then I get ال FN. Once I get ال FN multiplied by mu S, I got ال cap. لكن أنا قايل لي هنا إنه ال F horizontal كم؟ 7, which means it's less than the cap. Means the object is still will be static, stationary, did not move, did not slide, and the amount of friction is not 8.96, it will be 7. لأنه حتى if he applied 7.5, the answer will be what? 7.5. As long as it is less than the cap, I will oppose it with the same amount. If it exceeds the cap, I need to use السؤال اللي سألتكم إياه FK. يا شباب الأمور بدها مذاكرة، موضوع مش سهل ومش سخيف، بده مذاكرة. بس إذا بتذاكروا ما حيتمكنوا يخدعوك. هذا السؤال لما يجي 20% من الطلبة يحلوه، إلا الطالب اللي مركز حيجيبه وهو يضحك. طيب, we have 1 minute. Anybody has a question? Anybody has a question? Raise your hand if you have a question. طيب, let me see what's the, nobody has a question, so we'll see next slide. طيب, next slide we'll talk about it next time. So let's take a question. Mubarak Uheb.
Doctor, how did you know that B is not the normal force?
How did I know? He's telling you I applied a force of 7 Newton called B. ليه هو قال لك هذه normal force؟ يعني الفورس applied cannot be up, it can be any direction. ولا لا؟ صح ولا لا؟ هنا قال لك في vertical force 7. Yeah, it's okay. في vertical force 7. Why to assume it's the normal force? It's not the normal force. The normal force is still you need to, يعني لو كان هنا نرجع للسؤال معلش. اوبس هنا لو كان في هنا كمان فورس وكمان فورس وكمان فورس وتو فورسز داون وفي فورس with an angle هذه. I need to analyze. It will be a mess. I need to calculate the F normal. I need to include 5 forces here to calculate the F normal. مش شرط إذا up يعني خلاص normal force. طيب, I hope I answered you. Anybody has more questions? محمد المع. Muhammad.
Yes, Doctor. Why we
Yes.
said if n plus b minus mg equal to 0? We don't know that the acceleration is 0 because
انت عارف الاكسلريشن يا محمد. الاوبجكت لا دريلينج ولا flying. He's telling you he's in contact. He's in the surface. انت عارف لو في اكسلريشن على الواي كان هذا الاوبجكت فلاينج فوق او يحفر هنا. صح؟
Yes.
ما في حركه على الواي يا عزيزي. always احنا ليش دائما بنقول اف ان minus mg equal 0؟ المفروض نكتب may because we know it's not drilling and it's not flying. It's in contact with the surface. If he said it will fly up خلاص may واحسب الاي واي هذه. Okay. Okay, good question. What is your office hour? Office hours أنا it's posted but you need to reserve with me a spot. يعني ما أكون جالس أنتظرك. If you need an office hour, you contact me by email or tell me I need to have in the next office hour, I need to so that I will log in. Okay, important like this. طيب. It's posted on the website, all the office hours of all the faculty. Okay? طيب يا شباب, we exceeded the time. Inshallah, we continue next time.